A worse time. All right, so now we're back there. I need to come back here and join. All right. Got it. No audio. All right, now share screen. This should work. Okay, so the plan here was I wanted to go to just Blackboard and make sure that everybody sees where they can find some resources for helping you study. Okay, so there's this exam preparation tab that's over on the left. Justin, would you mind? Can you go grab the lights in the back? I just feel like you guys will be able to see better. And sadly, they don't go that way. So you have to turn off all of them. It's fine. Yep. Yeah, we're good. So if you go to this exam preparation, you will find, and they're actually up here for the entire course, you will find study guides for the exam and then practice things. So I will highlight these two. This is a practice exam and and I'm actually going to put up here. Right now, this is just the key. I'm going to put a blank version up there. Won't make sense for you guys since you are, we're going to be going through it now, nor for anybody who's necessarily watching the video. But if somebody wants to have a blank version that they want to try taking an exam, and then they can have a key to check it. I loved that you tried to make your own exam. Chris. Yep. I saw that and I was like, oh, that's pretty interesting. So, but just to take a second and go through the study guide. Okay, so I'm going to zoom in here. So this is probably kind of small. So this first, all the study guides are set up the same, where they'll list anything that you need to know how to do. And then things that are bolded are things that there's going to be particular emphasis on. So the majority of your first exam is going to be concepts related to unit conversion. And there's a good bit on naming. Now there's also, a problem on drawing compounds. So all of this is representative, but those are sort of like the big skills that we know are going to continue on. So just kind of running through, and you'll notice if you look at your quizzes, each of the quizzes is like 25 minutes, front and a back. My exams are 50 minutes and 2 fronts and backs. So not surprised, like they're all the same in that regard. So you can expect there to be 4 pages and then a combination of like a front page qualitative stuff and a back page more kind of computational stuff that you can get partial credit for. So you can just sort of see some of the different things. If you're looking at one of these things and you're like, I don't know what that skill is about, right? Go back to Blackboard. You can find that skill. You can look at the notes from it. You can see specific problems to practice and sort of work on there. But this is the extent of our first exam. Okay, and it highlights here suggested study strategies. Look at the problems that we did in class. Go through problems worked on in problem solving sessions. We really didn't, that was something I did the past couple of years, but students generally didn't go too much, and it was a lot of work on my part. So I don't have those anymore, but I think I'm going to I have sometimes found the links from last year's problem solving sessions and just posted them. Again, if people wanted to watch them afterwards, you can see just kind of some problem solving. And then highlighting if you're having problems working through problems, find ones in the skills sheet that have asterisks by them. And those are going to be ones that there's solutions and video solutions on Blackboard for. So just to take a second, and I want to make sure to orient everybody where you can find all this stuff. Let's say we're in our learning units folder here, and we're looking at this first part here, and you wanted some help with unit conversion, right? So if you look at the notes and homework sort of piece here, you'll notice that at the bottom, there's practice problems, and see how some of these have asterisks that are next to them. These problems that have asterisks all have practice problems that have a solution to them that you could kind of look at a static solution. So you can kind of look at or just a written solution. And if that helps you figure out the answer, great. And if you needed to watch a video of me working through that solution, then you click on this link and it's going to take you to a YouTube video that kind of walks you through the problem. So if you find that there's skills that you're a little bit rusty on, that's going to be a good way to sort of figure out how to scaffold your learning. So I want to make sure that everybody knows where all of those resources are. And again, I've sort of done an orientation already with where information is on Blackboard, but every time we have a class period, we cover one skill in a class period, right? So if you missed a class, for example, you can go and watch a video that is essentially the lecture that I give in the first half of that. You don't necessarily get the problems from that, but you get the background from it. People who watch them ahead of time will probably feel like they're hearing a broken record because it's the same stuff all the time. And then associated, for example, with skill 1.2, these are all the practice problems for it. Okay. And then here's even more unit conversion practice. So this was a video that I posted last year. So this was, I think, I don't know when this was, but these are two different videos from problem solving sessions I had that I recorded. Because when we did stuff over COVID, like everything was recorded. It didn't do anything in person. And so there's just lots of stuff that I had recordings from. So lots of resources to help you fill in gaps where you feel like there might be problems. Okay. All right. I think that's all that I wanted to do here. I'm going to stop sharing here. And then I'm going to start sharing with my iPad here. And this is where we should be able to get to, and you guys should see it here. And because I'm sharing the screen via Zoom, everybody who's watching a recording will see this. So exams are going to be set up the same way. So I figured it could be helpful that we could just go through this. You know, we've got about 45 minutes here. So ask questions, right? That's why you guys are here in person, so that if there's something that's still confusing, you can ask a question on. Front page of the exam always looks the same. You'll always get a copy of the periodic table with your exam. So the intent is nobody brings in anything with them for the exam. You have this resource. Highlighting too, you have to use a calculator, not a cell phone or anything like that. I will provide one if people forget one, but just make sure you bring calculator with you for the exam. If there's any additional information that you need, you know, it'll be provided here. Now, this first exam is pretty short, so there's actually not a lot of resources there. So the second page is blank. But as we learn more throughout the semester, this back page will get filled up more and more. And as you get the exam, most students rip off that front page and then they have their resources handy so that they can not have to flip back and forth on their exam. So let's just walk through these problems. And I think as you look through these problems, you'll recognize a lot of parallels to things that we had from our quizzes. So if you want to envision your exam being really quiz 1 plus quiz 2, version 2, it's gonna look a lot like that. Okay. I'm gonna give you guys a minute just to maybe write down some stuff here. Because I'm realizing I'm not gonna be able to do math in my head. There's some things I can do in my head, but I need to have my key here in order to know sort of some of the math answers. So let me go grab that and write some stuff down. All right, now as we keep going, you might not have, I want to make sure to get through this in sufficient time. So you might not have time to write down everything from every problem. But again, I'm going to put a blank version of this up on Blackboard. Right now, the key is available on Blackboard. but I want to make sure put a blank version up if anybody wants to practice. Okay, so identify whether the following are ionic or covalent. The easiest thing to identify or to be able to identify whether something's ionic or covalent is to ask what's making it from the periodic table, right? Is it a metal and a non-metal? That's going to be an ionic compound. Is it two nonmetals? That's going to be a covalent compound. So first one is ionic, second one is covalent. Then we've got ionic. Anytime you see a metal with something, you're going to call it an ionic compound. And then Epsom salts is ionic. Okay, so pretty straightforward. Do you notice sort of the first few problems here? My mother-in-law keeps calling me. Second here. You don't know this, and I have a review session right now. There's a little button. Power button. Hold it. And then when you're starting it, you'll like flash. Stop that. All right, sorry about that. Okay, perform the following calculations and then report your answer using the correct number of significant figures and units. So an addition problem, and then addition subtraction type problem, and then a multiplication division type problem. So remembering when we do multiplication and division, we're going to find the value that has the fewest number of significant digits, and that determines the number of significant digits in our answer. So if we're to put this in our calculator, we'd end up getting an answer that we want to have 3 significant digits in. Okay, now for this problem in particular, you have to be completely right on it. For other problems, I'll give you plus or minus 1 significant digit. But when I'm specifically asking you about significant digits, you have to get this one right. Most of the stuff that's on the first 2 pages here, there's no partial credit for. Okay, so the answer for this first part is going to be 21.4 liters. So the math would give us 24 point, oh, I hope my iPad doesn't die here. Will give us 21.4 liters. And then we need to round to 3 significant digits. Okay, it's good there. Okay, now when we're doing addition and subtraction, what matters is the number of significant digits to the right of the decimal place. So that's how we're going to determine the weakest link, whoever has the fewest. And we can see here, looking at this guy, that has only 1 digit to the right of the decimal place. And so we're going to have 1 digit to the right of the decimal place for our answer. So you do your addition and subtraction, and then when you round, we are going to have 168.3 millimeters. Make sure that you have the correct units with this. Looking at our first problem, it took grams and it divided by grams per liter, which ended up putting liter in the numerator. Does everybody see that? So it was grams divided by grams over liter. Those are canceled. So it gives us 1 over liter, which is liters. Okay, so you have to have the right units and the right number of significant figures with that. Problems that look similar to the quiz you probably just took. 2 isotopes of copper are copper 63 and copper 65. Give the number of protons and neutrons in an atom of each isotope. Okay, so if we need to use the periodic table to see that it is atomic number 29. So that's how we know where that is. Just take a second here. Let me flip back to this first page. We're looking at copper. We can see copper right there. So copper is atomic number 29. And so we're going to use that information in terms of the number of protons. The atomic number is the number of protons. And then for the neutrons, it's going to be the difference between the mass number and the number of protons. So for copper 63, okay, it's going to be 63 minus 29, which is going to be 34. And then copper 65 has 2 more proton or neutrons, so that's going to be 36. Everybody good? All right. Table that allows us to sort of think about all this information. So we've got things that are charged species. So we have to think about reconciling that. And then, you know, different things are unknowns that are here. So let's take this first guy. We've got a copper +1 ion. That's copper 63. So like we had above, copper is going to be 29 as its atomic symbol. If it's copper 63, it's going to have 34 neutrons. We actually have a repeat sort of that information that's above. Now here's where things get a little bit different. And a lot of people miss this on the quiz. If we are a +1 cation, that means we have 1 less electron than we have protons, because the protons are +1 charged, the electrons are -1 charged. So if we have something that's a 0 charge, they're going to be equal. If it's a +1 charge, that means we actually have 1 less electron, because 28 minus things and 29 plus things are going to have a net of +1. Does that make sense? A lot of people either didn't get that on the quiz or had it backwards. Okay. And even with this problem, this last piece could be left blank. You could take all of your information from up here and know that this must be a +1 cation, because I can see that there. Okay. Good with that one? All right. Now we've got something here that tells us we've got 54 electrons and something with no charge. So hopefully it makes sense that it's got 54 protons. When protons and neutrons match, that's when we have a situation. And my iPad, I think, might die here. So I'm going to try to plug it in. It is just one of those days. I have a long cord. Should be able to unplug this here. Plug it in there. All right, so we will stay charged here. All right, now I would look up on the periodic table and I'd see atomic number 54 is going to be xenon. And then to get the mass number, I'm going to add protons and neutrons together. So 54 plus 77 is going to be 131. Everybody good? All right, last guy here. I have a neutral argon atom. So if I look up argon, I can see that it's atomic number 18. So there's 18 protons, which also means there's 18 electrons since I have something that's uncharged. And because my protons and neutrons need to add up to 40, 40 minus 18 is 22. You guys good with that? All right. Had a lot of people who missed things with our nuclear equations. So let's go through that. Again, the key for the quiz is posted online, so you can check and see what's going on there. So write a balanced nuclear equation that shows the following. So alpha decay of polonium-218. So when we say that it's decay of something, that means polonium-218 is a reactant. So it's going to go on the left side. Now I have to go back to the periodic table, and just to save some time here, I'm not going to go back to the periodic table, but find where PO is, that's polonium, and you'll see that it's atomic number 84. So I've got polonium-218 that is undergoing alpha decay, which means I am going to put an alpha particle on the right side. And an alpha particle has a mass of 4 It has 2 protons, and whether you write it with the symbol alpha, you write it as a helium atom, however you choose to write it, the important thing is that you have the 4 and the 2. Now, one of the things I noticed when I was grading people's quizzes is sometimes people were not being consistent with mass number on top, sort of atomic number on the bottom. And certainly when you try to do your addition across, you're going to get the wrong stuff there. So what we need to do is we need to figure out what's left over. And we're going to have something that has a mass of 214 because it's 218 minus 4. And it's going to have a mass number of 82. Right? And we're looking at our periodic table and we can see that 82 is going to be lead. Yes. Mm-hmm. So we bombard an iron 56. We bombard iron 56 with an alpha particle. So when you hear bombardment with, that means it's a reactant. So an alpha particle for the quiz would be on the left side. So would iron 56. Does that make sense? And then on the right side, it says beta emission. Emission means that beta particle goes on the right side, and then we have to figure out what's left over.
So it's decaying, like for example, a alpha decay is pulling up land 218.
Mm-hmm.
Decay means we're taking the reactant and we're breaking it down pretty much.
So, and when it says alpha decay or alpha emission, right? That means that's going to be on the products or on the product side. If we see bombardment with, reacted with, that tells us it's stuff on the left side.
And forming into stuff on the right.
Mm-hmm.
It's almost like it's flipped almost.
So when we say formation of neon, that means neon's going to be on the right side. Okay. So in this case, it says formation of neon. So I'm going to put neon on the right side here. And it says through beta decay. You see that word decay, that tells me that the beta particle needs to go on the product side. If you were, now again, we don't really see bombardment with beta particles because we call that electron capture. But that is the same particle where you would have, so this is, let's finish out neon. It's neon 20. And we look up on the periodic table, it's going to be atomic number 10. You get rid of this here so we can see, okay? Neon 10, and then we have beta decay. So this is going to be 0, -1. And whether you write an E for an electron or beta for a beta particle, that's what that's going to look like. Okay, so now we need to figure out, well, what's on the left? We know it needs to add up to 20. And then this is going to be 9. Everybody see why it's 9? Okay, look up in the periodic table and see that's fluorine. So I could rewrite the same problem where it would be the same equation, but I'd say fluorine 20 undergoes beta decay to produce this particle. It would be the same exact equation, but now you have to figure out that it's neon 20. Do you see that? So, you know, Maddie, you've been making your own sort of problems. Ways that you can make your own problems is just look at a nuclear decay equation and see how many different ways you could write a question that describes that, right? Because that's a way of kind of putting those pieces together. Because in all of these, there's a piece that's missing. I don't necessarily describe all the pieces, but I can pick any one of those pieces to be missing. Good. Yeah.
What is the case that where beta or alpha is on the left side?
So if alpha, so this says alpha decay, alpha particles on the right, bombardment with alpha particles on the left. Okay. Now with the beta particle, we're either going to see beta emission. That means that electron is on the right. We call it electron capture if the electron is on the left. Okay. How many total electrons are in a single nitride ion? So N 3-, and I think this one was on like a practice quiz that you guys had as well. So a nitride ion, you have to say, okay, nitrogen, if it was neutral, would have 7 protons and 7 electrons, but I'm going to make it into a nitride ion, which means adding 3 electrons to give it that 8 in its outer shell. We know that it's -3 here. So that means we're adding 3 electrons. And so then we're going to get a total of 10 electrons. Everybody good? We've got a whole page of naming. Okay, so the first page is kind of like non-partial credit stuff that's related to everything else. And then you're going to see a whole page on naming. So I'm going to ask you guys right now, where are you at specifically with naming? Do you want to go through naming, or would you rather work on some other, other stuff from this? Okay, so sometimes it's asking you to kind of just name or think about polyatomic ions. So that's sort of just like a part of something. So we can probably go through these fairly quickly. And these are just ones you need to know, right? And that's why I'm happy to go through these, but sometimes the best way is just practice, 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 practice. There's lots of practice sheets that are available. There's a folder in Unit 2 that's called Help with Naming. And if you go all the way down to the bottom, is a list of just worksheets that have blank, and then the key is at the end, so you can check your work. So Maddie, I know you tried to make some of your own problems, which was great, but the challenge with that is you don't have the ability to check your answers. So there's a whole bunch of worksheets that are in that folder that can help you practice that. Okay, so let's go through these. I'm going to go through them kind of quickly so that we can get through them and then kind of move on to some other stuff. So we've got a bunch of polyatomic ions here that we have to give names of. So this is bicarbonate. Now these ones that have like halogens with oxygens, and you could see any flavor of this with chlorine, bromine, and iodine. So there's like 12 different options. You have to look at how many oxygens that are there. It's either going to have 1, 2, 3, or 4 oxygens. Okay, that has 1 oxygen. That's the hypo sort of version. Then we're going to have bromite in the case. So if we went through the BRO, that would be hypobromite. BRO2 is going to be bromite. BRO3, which is what we have here, is bromate. And then perbromate is BRO4. And they all are -1 charged ions. Okay. We've got a lot of these here that have multiple options for the number of oxygens that they have, which can make them confusing. If we had SO4 2-, that would be sulfate, but this is sulfite because it only has 3 oxygens. So this is sulfite. And then the nitrogen versions come as NO3 or NO2. This is the 8 version of it. So this is nitrate. Everybody good? Make sense? Then we have to be able to go the other way. And I will say this is actually the more important way, because as we move forward with things, I'm more likely to give you chemical names that you need to make a formula from, maybe put it in an equation, balance the equation, do stoichiometry like we did in class. Okay. So cyanide, we need to know is CN-. Phosphate, PO4 3-. Sulfide is S2-. So as you practice these, if you're finding ones that you get wrong, see if it's because it has a similar name to something else. Like people get sulfide wrong a lot because they're thinking it's sulfate or sulfite. Okay, so as you're studying these, if you have flashcards, try putting all the ones that sound similar together and say, can I distinguish these because they all look the same? Same thing if you're looking at a chemical structure. Look at S2-, SO3 2-, SO2 2-. SO2 without a charge, that's not a polyatomic ion, that's sulfur dioxide, right? Acetate. Some people will write acetate like this because they've learned it that way. That's okay. But we can also write it as C2H3O2-. Both of those are acceptable. They're the same molecular formula. It's just one of them's more an organic chemistry sort of flavor of it. Okay, and then we have a whole laundry list of ones that are kind of 6 of them going in the forward direction and then going in sort of the reverse direction, making a name from a formula or a formula from a name. Okay, so same strategy that I always do. We're going to kind of have this so that if there's times that we need to give a charge for something, we can. This guy's going to be ammonium sulfate. So with these, highly encourage people to break them down into their ions first, because that makes sure that you recognize that this is going to be iron 2 oxide. And we can either write it as iron 2 oxide with that 2 in parentheses, or we can use our system of recognizing that iron comes as +2 and +3. So +2 is the lower oxidation number, which means it's the ferrous, not ferric name. So ferrous oxide is also a correct name here. Here's one that we have to name as an acid. Okay, so what we need to do is we need to take the proton away, the H plus away, and look at the ion that's left. We have to think about naming the polyatomic ion, which is going to be nitrite. And if it's the ite version and not the ate version, the ite version becomes the OUS acid. So it becomes nitrous acid. When you start seeing things that grab stuff from the same side of the periodic table, 2 nonmetals, we know we need to be naming it as a covalent compound, which means we need to use those Greek prefixes to tell us how many of each thing we have. The first thing we treat as a cation, when we name cations, we name it as we see it at the periodic table. The second thing gets named like it was an anion. So we're going to see a chlorine and then an oxide, and we have to use Greek prefixes to tell us how many we have. So this is going to be dichlorine, hexa oxide. And I've seen it both ways. I am not truly certain which is 100% correct. If you have the A there or not, I would accept hex oxide, because sometimes if they have 2 vowels together, they get rid of them. Definitely if it's 2 of the same vowels, you'd get rid of it. But so I'm fine with either hexa oxide or hex oxide. Okay. 2 more here of this flavor. We're going to have Na plus and then HCO3 minus. So that's going to be sodium and bicarbonate. Splitting this guy apart, we've got copper 2 plus, and then chloride, which means this is copper. Uh-oh, did my Apple Pencil died? My goodness, I've been using my iPad all day, so it's not happy. So we're going to have copper 2 chloride. I'm going to give this a minute to charge. We're going to run through these other guys. So while I'm charging here for a second, we're going to come back and do these. Let's look at some of the other questions we have, and then make sure we've got a, what just happened? Oh my gosh, my iPad just died because I was trying to charge my pencil. It is a day. Let me put this back here so that I'm charging it. All right. So let's do this for a second, because we can still see stuff here. I might not be able to write, but let's go do this. You guys can see this, which means I'm sharing my screen. I'm going to just pull up the exam key and let's talk through some of this stuff that we have with the other ones. And that'll actually probably save us time, because if we only have like 15-20 minutes left, it'll allow us to make sure we get through as much as we can. So let's go through the rest of those nomenclature problems that we have there. Okay. So once we get to ones where we have to write a chemical formula, this is the more important direction. So if you're missing some of these ones that are up here, that's better than missing the other ones, because taking a name and getting a right chemical formula is important, because if you have the wrong chemical formula, then you can't balance the equation properly. You're not going to get a correct molecular weight. Like everything downstream is going to be off if you don't get the chemical formula right. So here we can see we've got barium. Let me zoom in here. We've got barium oxide. So barium is always a 2+ cation with oxygen, which is a 2-. So that's going to be BaO. Hypochlorous acid. So now we need to work backwards and say, what is the anion that came from? Well, it must have been hypochlorite. That's chlorine with only 1 oxygen and a -1 charge. So if I make that into the acid, that means I'm adding 1 H+. Okay. Here's another one of these ones where, oh, I give you sort of the common name. Stannous is tin. Okay. And when we have the OUS, that's the lower charge form of tin. Tin is one of those that comes as +2 and +4. So stannous means it's SN2+. And then sulfite is SO3 2-. So I put those pieces together. Simplest whole number ratio is SN-SO3. Methane is one of those small molecules that I need you to know the common name for. Okay, so common name for methane, or common name is methane for CH4. And then we've got lead-2 nitrate. So lead-2 is a lead with a 2+ charge, NO3-. So then we're going to have PbNO3 2. Last one, and now that you've done something in lab, maybe thinking about hydrated salts is a little bit easier to think about because you had a hydrated salt, that copper salt that you had to get the water off of. But magnesium is always 2+. This is nitrite, so NO2-. And then we know we've got 3 waters here, trihydrate. Okay, so magnesium nitrite looks like this, MgNO2, and then we put a dot. That Greek prefix tri tells us 3 hydrate water. Good. All right, so let's move on to next part. So, and you'll see as we go through these problems that they kind of start simpler and single skill, if you will, and then kind of build and get a little bit more involved. So just like you had on your quiz, our quiz 1, you had some kind of basic 1-step unit conversions. So these problems allow me to sort of assess as I'm grading, are people okay with doing like 1-step unit conversions? But then once we start putting them together, multiple step, it's a little bit harder, or actually having it in the context of solving a problem, it's even harder, right? So that's what these 3 problems kind of go through. Some simple basic unit conversions. Remember, there's ones that you need to know, those prefix conversions you need to know. So you'd need to know that 1 liter is 1,000 milliliters, right? We talk about how we're going to have a big little relationship there. We need to know that the bigger unit is liters, and that goes with the smaller number, 1. Okay. Something like this is provided on the front sheet of your exam. So you would not need to know this unit conversion, but you need to know how and when to use it. And then converting Kelvin to Celsius, or the other way around, is important. You're always going to have positive values if something's in Kelvin. You can have negative degree values if something's set Celsius, but how you interconvert is you basically, if we're going in this case to Celsius, we take our Kelvin temperature and we subtract 273.15 and we get a -109. If we were going in the opposite direction, we would add 273. Okay. A little bit more involved unit conversion here tells us that the average density of the Earth is 5.52 grams per cubic centimeter. We want to convert then that to kilograms per meter cubed. So this involves a basic unit conversion here to just convert grams to kilograms, and then one of those special unit conversions that require us to recognize we need to cube that, right? Everybody good? Makes sense? All right. Then there's a unit conversion that involves a problem, right? So here's a problem. where we have a small metal cube. So it's a cube, so we know each side is 13.3 millimeters. We know what the weight is, and we want to calculate density. Okay, so density is a relationship between mass and volume. So they gave me the mass as 24.79, and they didn't give me the volume, but I can figure out the volume by length times width times height. And if I use that 13.3, I'm going to get an answer in terms of cubic millimeters. But if I come over here and I recognize the densities of these metals that are given, they're grams per cubic centimeter. Okay, so what I can do is I can get an answer that's in terms of grams per cubic millimeter, and then I can do a single unit conversion to convert millimeters to centimeters. You guys following? Is that okay? Again, one of those situations, I have to make sure I have got that cube in there. And so I'm going to have something that has a density of 10.5 grams per cubic centimeter. And lo and behold, that density tells me that that's probably silver. Questions on that? Yes, Justin, you almost.
I was thinking.
So I'll give you a minute to look at it because that's not one that we sort of worked through as we did. So one of the things to also remember, there are problems that, remember, we can measure volume in terms of length measurements. So it's always length times width times height, but then we're going to have cubic length measurements. It's going to be meters or centimeters or millimeters, okay? When we're talking about another way to measure volume, we can think about liquid measurement, okay? So a really important unit conversion that allows us to think about that is, and I'm going to write this up here on the board because I know people watching the video will be able to see it because my camera is pointed there. This is an important unit conversion. 1 cubic centimeter is 1 milliliter. Okay, so that can allow me to change. Well, maybe you can't see it very well. It's backwards. All right, so maybe you heard me say it. 1 cubic centimeter is equal to 1 milliliter. That's a unit conversion that I want you to know. That's one of those special ones, okay? But that allows us to change from volume in terms of length measurements to volume in terms of liquid measurements, like milliliters or liters, okay? So problem 12 is an example of, it's a unit conversion problem, but it kind of has a little bit of a story to it and something that you need to sort of solve, a puzzle to solve, if you will. Same thing is true with this problem. Okay, this NyQuil problem, right? It's asking us to figure out how much a case of 36 bottles weigh. And one of the things I'll tell you, I'm never going to give you a problem where it's not something that you could sort of try to ballpark an answer or ask yourself, does this make sense? I try to give you problems that you can sort of like wrestle with, does this sound right? Or does it sound like way like out of left field, right? So if we're doing a problem like this and you got that a case of NyQuil weighed 21,000 pounds, ooh, that doesn't sound right, right? So I'm never going to give you a problem that is a problem you could think about conceptually and have it be that the numbers are way off, okay? So when you have a problem like this, you have to be able to pull out from the problem all the pieces. Every time we have one of these relationship quantities, it's a piece of information I either got from the problem prompt or it's something that I need to know. So sometimes like this says, you know, the density is 1.497 grams per cubic centimeter. So that's where that piece is. So that was given directly. Okay. But the words up here say that NyQuil comes in bottles containing 177 milliliters. I need to figure out how would I put that number into a unit conversion that I could use? Well, I could say that 1 bottle equals 177 milliliters. And as soon as I make that relationship that this equals that, I've created a unit conversion that I can use. So these are almost like little puzzles. Try to create as many equalities as you can, because that means you can use them as a unit conversion. and then just try to stack your unit conversions together so that units that you don't want go away, and you start walking towards the final answer of units that you want. So this final answer, I want to know, I want to have an answer that ends up in pounds. What's given to me? I've got 36 bottles. So start with 36 bottles, and how can I walk there? Well, 36 bottles can be converted into how many milliliters that is by using this unit conversion. Okay, I ultimately need to get to a mass, and it's like, well, I've got this density that's grams per centimeter, but that's measuring volume as a length measurement. And so I can have this magic conversion here. This is the one I was trying to write on the board, but didn't show. I can have this magic unit conversion that kind of allows me to change from units of length measurement for volume to units of volume that we're typically used to seeing. And then I can say, you know what? I can walk from cubic centimeters to grams. I can walk from grams to kilograms. And the front page of my exam tells me how to walk from kilograms to pounds. Okay, so you just need to figure out how to line up these unit conversions so the units you want to go away, and you're walking one step closer to the units that you want in your answer. So it starts out by saying, where do I want to go? I need to have something that has units of pounds. So I want to end up with pounds in my numerator. I start out with number of bottles. So then you just figure out these pieces that go in the middle. And very often people won't even necessarily know how to do the problem, but they'll know how to pick out the unit conversion pieces, and then they just know how to stack them together. Okay, so think about that as you're working through these problems. Okay, and I think there's only 2 more problems here. I will always, the last problem on the test is always going to be a little bit of a challenge problem. Okay, it's usually not worth much. You can see it's only worth 7 points here, okay, out of a 150-point exam. So it's not a lot, but I want to challenge people. I want to see, could somebody really solve kind of a more challenging problem? So definitely leave that problem to the end. And if it's something that you don't get to, don't stress, because it's a small number of points in terms of the overall piece. But you're going to see something that's going to require you to draw a structure and sort of think about doing some pieces. So this one is sort of like a little bit of an integrated problem. You have to look at a molecular picture. Okay, molecular pictures kind of identify the atoms that we have here. And so you'd have to look at these molecules and say, this molecule has an oxygen and 2 nitrogens. So that's going to be N2O. If I had to name that, it would be dinitrogen monoxide. Figure out a molecular weight for it, right? And then try drawing a Lewis structure for it. Okay. And so there's not a lot of options we can have here for this guy. And then this guy is dichlorine monoxide. So you're going to see problems where you're going to need to draw me something. And these might end up being separate pieces, but you're going to have to draw stuff, maybe talk about the shape of it. I don't think I had like telling me what the shape of these guys are, but that was something that was just part of the quiz you just had. Figuring out molecular weight, you're going to have a problem that's related to that. I don't know if it'll be an all integrated piece like this. Okay, questions on that guy? How did you guys do on your quiz problem with NH3? That was.
I did fine. I just didn't know the shape. I didn't know what shape.
So, and that's one of those things, look back at that. There's a chart that kind of shows all of them. And so that I really try to not have a lot of memorization in the class, but particularly early on, as we're building our toolbox of language here, there are some things we need to know. So yeah, electron group arrangement for ammonia is going to be tetrahedral because there's 4 things around it. Okay. But because one of those things happens to be a lone pair, the code is going to be AX3E.
I also was, I got one wrong.
Okay.
I don't.
So the arrow is always going to point towards the more electronegative atom. It's never going to point towards hydrogen. Okay. So if there's hydrogen there, it's always going to point towards the other atom, unless it's carbon and hydrogen, which is not a polar bond. Okay, but if it's something bonded to hydrogen, like oxygen bonded to hydrogen, it's always going to point to oxygen. Sulfur bonded to hydrogen, it's always going to point to sulfur. You will never have an arrow point towards hydrogen if you have to draw a dipole. Good question. Justin, do you have anything else?
For yeah, no, for mine, I did actually good. I just forgot to write the electron.
Got it.
Gave me a point.
Yep. So, and in hindsight, I probably should have like literally made a list of things for people to write stuff in, because then people would have known like, hey, I have a blank here. I didn't provide an answer for that, rather than a list.
Yeah, I was a little confused. Like, is this the electron group? I almost I'm like, wait, which is the electron group again? Which it made me confused. But
Yep. So the electron group always just describes how many things are around it. And then if some of those things are lone pairs, it's going to have a different molecular group. If there's all atoms, the electron group and the molecular shape are the same name. Okay. And this problem is just, it's one of these unit conversion problems that requires you to be a little bit creative. Okay. And think about this. So this says we've got a sample of a diamond and we give the density of the diamond and it's pure carbon. So if the average mass of a carbon atom is this, how many carbon atoms are present? So initially the question is asking how many. You should be thinking, I got to use Avogadro's number, right? If you have something that asks the question, how many, you got to be using Avogadro's number. So the pieces that we can sort of put together here are, well, here's a relationship quantity that's in the problem. 3.51 grams equals 1 cubic centimeter. I know that one carbon atom weighs this amount. I get that from up here. So once you have these pieces, and I know I want to get to an answer that has the number of carbon atoms, you could actually work backwards from these. Like some people, when they're playing chess, they'll work backwards from a move to kind of try to figure out what are the multiple steps that I want to go together. If I know that I want to end up with how many carbon atoms, okay. Oh, this is a problem. This is why this is tricky. I forgot. This says how many. You are not going to use Avogadro's number for this because I know that the mass of the I have what one carbon atom weighs. So I'm going to end up getting to the number of carbon atoms. I got ahead of myself. I was thinking about a different problem here. So this one, I know I can walk from carbon atom to mass. I can walk from mass to volume. I can change sort of the volume that I have here so that I can take the information that's given of volume in length measurement. And then I can string all these unit conversions together. So yes, that's that. And as I'm looking at my notes down here, if you use Avogadro's number, you won't get the right answer. Okay, but there's going to be one problem at the end. It's kind of like, it's a challenging problem, but not a lot of points. So don't stress about it. If you don't see, I would save it to the end. And if you find that you've checked off everything else and you're like, I feel good about this, I'm going to try that. I'm going to try that challenge problem. Okay. Questions? All right. I'm going to post a blank version of this. Again, probably not relevant for anybody who is watching this or for you guys, because we just sort of went through it. But if you want, you can go, let me go back over here. You can try, if you want to try another problem, here's Dr. Brown's exam, right? Looks very similar in terms of the kinds of stuff that he has on it. Again, a whole page of naming. I mean, our exams are very similar, you know, but this can be something that you can practice with some more of these. Okay. Thanks guys for coming, and other students will benefit too, because if nobody shows up, I don't talk to myself. So I'm glad you guys showed up so that there's something for other people here.